Ocean thermal energy conversion. Ocean thermal energy conversion, or also known as OTEC, is a process that can produce electricity by using the temperature difference between deep cold ocean water and warm tropical surface water. It is an energy technology that converts solar radiation to electric power. It utilizes the world's largest solar radiation collector. The ocean contains enough energy to power all of the world's electrical needs. Oceans cover more than 70% of Earth's surface, making them the world's largest solar collectors. OTEC is a renewable energy technology that converts solar radiation into electric power by use of world oceans. OTEC process uses temperature difference between cold deep water and warm surface water to power a turbine to generate electricity. The working principle of OTEC. This plant works on the principle of a closed Rankine cycle. Warm water is used to evaporate working fluid like ammonia or hydrocarbon refrigerant. Evaporated fluid expands in a low-pressure turbine, which is coupled with a turbo alternator to produce electricity. Types of electricity conversion systems. There are three types of electricity conversion system. 1. Closed OTEC cycle power plant. 2. Open OTEC cycle power plant. 3. Hybrid cycle OTEC power plant. In a closed cycle OTEC, warm seawater vaporizes a working fluid such as ammonia, flowing through a heat exchanger or an evaporator. The vapor expands at moderate pressures and turns the turbine coupled to a generator that produces electricity. The vapor is then condensed in heat exchanger using cold seawater pumped from the ocean deeps through a cold water pipe. The condensed working fluid is pumped back to the evaporator to repeat the cycle. The working fluid remains in a closed system and circulates continuously. The heat exchangers are a large and crucial component of the closed cycle power plant, both in terms of actual size and the capital cost. In an open-loop OTEC cycle, the seawater is itself used to generate heat without any kind of intermediate fluid. Open cycle OTEC uses the tropical ocean's warm surface water to make electricity. The open cycle consists of flash evaporation of a fraction of the warm seawater by reduction of pressure below the saturation value corresponding to its temperature. The expansion of the vapor through a turbine to generate power. The compression of non-condensable gases from the seawater streams at the low operating pressure to pressures required to discharge them from the system. The hybrid OTEC cycle combines the features of both the closed cycle and open cycle system. Warm seawater enters a vacuum chamber where it is flash evaporated into steam, which is similar to the open cycle of the evaporation process. The steam vaporizes the working fluid of a closed cycle loop on the other side of an ammonia vaporizer. The vaporized fluid then drives a turbine that produces electricity. The steam condenses within the heat exchanger and provides desalinated water. The OTEC system application. OTEC can be used to generate electricity, desalinate water, support deep water mariculture, and provide refrigeration and air conditioning, as well as an aid in crop growth and mineral extraction. Electricity production. The two basic OTEC system designs have been demonstrated to generate electricity, the closed and the open cycle. Desalinated water can be produced in open or hybrid cycle plants using surface condensers. A surface condenser can be used to recover part of the steam in the cycle and to reduce the overall size of the heat exchangers. One way to produce large quantities of desalinated water without incurring the cost of an open cycle turbine is to use a hybrid system. In a hybrid system, desalinated water is produced by vacuum flash distillation and power is produced by a closed cycle loop. In refrigeration and air conditioning, the cold seawater made available by an OTEC system create an opportunity to provide large amounts of cooling to operations that are related to or close to the plant. The low-cost refrigeration provided by the cold seawater can be used to upgrade or maintain the quality of indigenous fish, which tend to deteriorate quickly in warm tropical regions. The cold seawater delivered to an OTEC plant can be used in chilled water coils to provide air conditioning for buildings. The mineral extraction. The ocean contains 57 trace elements and salt dissolved in solution. The Japanese recently began investigating the concept of combining the extraction of uranium dissolved in seawater with wave energy technology. They found that developments in other technologies were improving the viability of mineral extraction process to deploy ocean energy. The platforms of OTEC. One land-based power plant and sea-based power plant are also known as floating plant. There are OTEC power plants in the world. In Hawaii, Japan, South Korea, and southern China.
Power plant analysis of ocean thermal energy conversion or OTEC. But first, let us know what is OTEC. Ocean thermal energy conversion or OTEC is a marine renewable energy technology that harnesses the solar energy absorbed by the oceans to generate electric power. The sun's heat warms the surface water a lot more than the deep ocean water, which creates the ocean's naturally available temperature gradient or thermal energy. OTEC uses the ocean's warm surface water with a temperature of around 25 degrees Celsius or 77 degrees Fahrenheit to vaporize a working fluid, which has a low boiling point, such as ammonia. The vapor expands and, and, and spins a turbine coupled to a generator to produce electricity. The vapor is then cooled by seawater that has been pumped from the deeper ocean layer, where the temperature is about 5 degrees Celsius or 41 degrees Fahrenheit. That condenses the working fluid back into a liquid, so it can be reused. This is a continuous electricity generating cycle. The efficiency of the cycle is strongly determined by the temperature differential. The bigger the temperature differences, the higher the efficiency. The technology is therefore viable primarily in equatorial areas where the year-round temperature differential is at least 20 degrees Celsius or 36 degrees Fahrenheit. How OTEC works. OTEC works. The warm surface ocean water is pumped to the evaporator, which transfers heat to the working fluid. Working fluid is turning into a high pressure vapor. The turbine generator spins as the vapor rushes through it. In the low pressure condenser, the vapor is cooled by the nearly freezing water brought up from the ocean depths. After condensing, the working fluid is sent back to the boiler to be reused and to repeat the cycle. 3 OTEC basic design system. First, closed cycle. Second, open cycle. Third is the hybrid cycle. Closed cycle. In the closed cycle OTEC system, warm seawater vaporizes a working fluid such as ammonia flowing through a heat exchanger or evaporator. The vapor expands at moderate pressure and turns a turbine coupled to a generator that produces electricity. The vapor is then condensed in condenser using cold seawater pumped from the ocean's depth through a cold water pipe. The condensed working fluid is pumped back to the evaporator to repeat the cycle. The working fluid remains in a closed system and circulates continuously. The second system is the open cycle. Open cycle system, warm seawater is the working fluid. The warm seawater is flash evaporated in a vacuum chamber to produce steam an absolute pressure of about 2.4 kilopascals. The steam expands through a low pressure turbine that is coupled to a generator to produce electricity. The steam exiting the turbine is condensed by cold seawater pumped from the ocean's depth through a cold water pipe. If a surface condenser is used in the system, the condensed steam remains separated from the cold seawater and provides a supply of desalinated water. The third one system is the hybrid cycle system. A hybrid cycle combines the features of both the closed cycle and the open cycle system. In a hybrid OTEC system, warm seawater enters a vacuum chamber where it is flash evaporated into steam, which is similar to the open cycle evaporation process. The steam vaporizes the working fluid of a closed cycle loop on the other side of an ammonia vaporizer. The vaporized fluid then drives a turbine that produces electricity. The steam condenses within the heat exchanger and provides desalinated water. And that is the three cycle of OTEC. Proposed projects of OTEC. Mackays Ocean Thermal Power Plant, Hawaii. OTEC Power Plant in Hainan Island, China. Okinawa Prefecture in Japan. OTEC Plant on Guam. OTEC Plant, U.S. Virgin Islands and in Bahamas. Republic of Kiribati. OTEC Power Plant in Maranique. OTEC Power Plant in Maldives. To know more about OTEC, let's watch and learn in this video.
Did you know that we can use the natural temperature differences in oceans to produce clean electricity, day and night, and all year round? This is called Ocean Thermal Energy Conversion, or OTEC. It works best in the tropical equatorial zone. Here, the ocean temperature difference is at least 20 degrees Celsius throughout the year. How does it work? The ocean's warm surface water vaporizes a working fluid with a low boiling point, ammonia for example. The vapor expands and spins a turbine that is coupled to a generator that produces electricity. The vapor is then cooled by cold deep seawater. That way, the working fluid condenses back into a liquid and you can reuse it. This makes it a continuous electricity generating cycle. OTEC can become an important renewable energy source. At Delft University of Technology, we do research to try and make this happen. For example, by helping to develop offshore technology and process equipment for OTEC. If you want to find out more about ocean energy, go to the Delft University of Technology Ocean Energy website.
That's all and thank you.
Here are the following environmental, health and safety, social and ethical consideration in ocean thermal energy conversion technology. 1. Sea surface temperature anomalies and biosimulation. Anomalies show differences from average conditions over for the time period of coverage. Scientific literature has recently shown that SST can significantly affect high-impact weather. Biostimulation involves the modification of the environment to stimulate existing bacteria capable of bioremediation. Bioremediation is a branch of biotechnology that employs the use of living organisms like microbes and bacteria in the removal of contaminants, pollutants, and toxins from soil, water, and other environments. 2. Biofouling. Biofouling is the accumulation of unwanted biological material on surfaces, as found in medical, marine, and industrial applications. To have effective heat transfer, it is necessary to protect the heat exchangers from biofouling. It has been determined that biofouling only occurs in OTEC heat exchangers exposed to surface seawater. 3. The use of biocide and ammonia. The use of biocides and ammonia are similar to other human activities. If occupational health and safety regulations like those in effect in the USA are followed, working fluid and biocide, most probably anhydrous ammonia and chlorine, emissions from a plant should be too low to detect outside the plant sites. A major release of working fluid or biocide would be hazardous to plant workers and potentially hazardous to the populace in surrounding areas, depending on their proximity. 4. Organism impingement. Organisms impinged by an OTEC plant are caught on the screens protecting the intakes. Impingement is fatal to the organism. An entrained organism is drawn into and passes through the plant. Entrained organism may be exposed to biocides and temperature and pressure shock. Entrained organisms may also be exposed to working fluid and trace constituents, such as trace metals and oil or grease. Intakes should be designed to limit the inlet flow velocity to minimize entrainment and impingement. 5. Commercial and recreational fishing. OTEC plant construction and operation may affect commercial and recreational fishing. Fish will be attracted to the plant, potentially increasing fishing in the area. Enhanced productivity due to redistribution of nutrients may improve fishing. However, the losses of inshore fish eggs and larvae, as well as juvenile fish, due to impingement and entrainment and to the discharge of biocides may reduce fish populations. The net effect of OTEC operation on aquatic life will depend on the balance achieved between these two effects. Through adequate planning and coordination with the local community, recreational assets near an OTEC site may be enhanced. Other risks associated with the OTEC power system are the safety issues associated with steam electric power generation plants, electrical hazards, rotating machinery, use of compressed gases, heavy material handling equipment, and shop and maintenance hazards. Because the CCOTEC power plant operates as a low temperature, low pressure Rankine cycle, it poses less hazard to operating personnel and the local population than conventional fossil fuel plants. It is essential that all potentially significant concerns may be examined and assessed for each site and designed to assure that OTEC is an environmentally benign and safe alternative to conventional power generation. The consensus among researchers is that the potentially detrimental effects of OTEC plants on the environment can be avoided or mitigated by proper design.
Find the quantity of water to be pumped to OTEC plant working with surface water at 27 degrees Celsius and with cold water at 8 degrees Celsius. at a depth of 600 meters from the surface to obtain 1 megawatt of thermal energy. Assume the density of ocean water is 1010 kg per cubic meter and the specific heat of water is 4200 joules per kilogram Kelvin. So we have the given the surface temperature is equals to 27 degrees Celsius. Convert it to Kelvin, so 300 Kelvin, and the cold water temperature is 8 degrees Celsius equals to 281 Kelvin. And the work is 1 megawatt or 1000 kilowatts. Cp is 4200 joules per kilogram Kelvin. So we have to find the value of the volume flow rate. So first we use the formula of Carnot efficiency, which is given by n is equals to 1 minus T2 over T1. Then we plug in the given values, so we get n is equals to 0.063. And next is the actual efficiency of heat engine. Since we have the value of n, which is 0.063, we plug it to the formula of n is equals to work done all over the heat supplied. So plug in the values and then we get 15,873 kilowatts. Then multiply it by 1,000 to convert it to watts. So we get 15,873,000 watts. And next is we use the formula for the heat, which is given by m times Cp times the delta T. So plug in the given values or the known values and then we get the mass flow rate equal to 198.909 kilograms per seconds. So lastly, to find the volume flow rate, we use the formula in finding the density and then we plug in the values and then we get 0.196939604 cubic meters per seconds. Then we multiply it by 3600 seconds to convert it to R. So we get the volume flow rate is equals to 708.982 cubic meters per hour.